Astronomers have looked at millions of stars in our galaxy, but they've never seen anything quite like this one. It's known as Tabby's star.
You have a star that's fading and a star that does regular, irregular dips in its light. Now, those two things don't normally go together.
This unique star captured the attention of the global news media.
Possibility of an extraterrestrial civilization.
Why haven't they made contact with us?
And the imaginations of millions.
You could have a complex system with multiple stars orbiting around this star.
Maybe there's some sort of strange cloud in the outer solar system.
I think maybe some people feel that we don't want it to be aliens. I would love it if it's aliens.
There is no explanation for what's going on with this star. It's bizarre. In fact, some have even suggested maybe alien technology is responsible. I'm headed off to Canberra to see if I can shed some light on the mystery. Aliens on the moon, you're telling me?
Aliens on the moon. It actually just turned out to be aliens in Los Angeles because there was radio stations from LA bouncing off the moon and coming back to Western Australia. So,
Brad Tucker is Australia's leading expert on the Kepler Space Telescope. He uses it to look for supernovas, black holes. But he's curious as to what Kepler saw when it looked at the light from Tabby's star. The citizen scientist found that it was weird, is that right?
So the citizen scientist alerted, and it's actually Tabby herself who said, hey, this star is weird.
The star didn't get tagged as a exoplanet target, but it was tagged as, something that didn't really look like anything else.
It was originally known by its Kepler input catalog number, so KIC followed by some phone number that I can never remember. Tabby herself calls it the WTF star, but so we just called it Tabby's star because she was the first one that showed it to us.
The data in 2009 is interesting because this is pretty much the first dip. When I say dip, I mean the star's drop in brightness. Then in 2011, there was a very, very large event that dropped down by 15%. And then at the very end of the Kepler mission, things start to get really crazy and we see many, many dips. This lasts for about 3 months at a time until the Kepler mission ends, and then there's nothing.
A dip in light occurs when a planet passes in front of its star. A transit of Jupiter, say, would make only a 1% drop in light. Tabby's first instinct was to think that the change in the light's flux was due to a data error from the Kepler Space Telescope.
Since then, however, a lot of people have checked, including the Kepler team at NASA, and everyone agrees that it really is the star getting dimmer, not some problem with the telescope. If there were alien civilizations that build massive structures around their stars, as some people have hypothesized, Kepler would discover them and that they would look something like the dips that we saw around Tabby's star. Now, the problem with the hypothesis that this might be alien megastructures is it's very hard to test. We don't know what an alien megastructure would look like, so there's really nothing we can do to show that that's what it is or isn't. So it's what I call a hypothesis of last resort.
So this WTF star, what are the chances of being aliens, you think?
What are the chances of being aliens? Well, what are the chances of me eating all the food? I'm probably not going to manage it. I might try, but I won't manage it. But we have to consider everything on the table because it's that weird.
I mean, it's feasible, very, very unlikely, but it's certainly feasible that it's alien technology, right? That fits the data.
If all of the options are weighed, it is a hypothesis that is not completely ruled out, just as lots of things are. But it's the one time you can probably say aliens aren't ruled out.
And what are some of the possible natural explanations?
There's always this simple example that you get orbiting planets, but there's multiple of them. You're taking care of my sausages. Yeah, I'll take care of the onion and tangerines, right? So if you imagine there's not just one planet orbiting around the star, but multiple of them, and perhaps they're actually orbiting around each other. And when they move around, you see various dips. So maybe there's a complex planetary system that is also creating what we're seeing.
What other possibilities are there?
Could be a bunch of comet fragments orbiting this star, but they also say that there should be a lot of infrared emission, but there's none.
Yeah, I mean,
No
that's
infrared light.
extraordinary in itself, though, isn't
That's
it?
right.
When citizen astronomers originally discovered Tabby's star, it really looked like there must be something very close to the star blocking the light. All of the measurements that we've taken of the star, including with the Spitzer Space Telescope, have revealed that there isn't any extra infrared radiation coming from the star. So that means there can't be anything very close to the star blocking the light. So we started to look for some more outlandish possibilities, something between us and Tabby's star, not going around Tabby's star, not very close to it, but in the interstellar medium, which is the gas and dust pervasive among the stars in the galaxy. Perhaps there is some rare phenomenon where these dense clouds can form and pass between us and the star temporarily.
Look good.
That's right. I think the alien megastructure might be calling us for lunch.
Brad has looked at the Kepler data in a different way, and he still thinks that a data glitch might be the explanation. So Kepler's pretty simple, really, in the way it looks for planets around other stars, isn't it?
That's right. It's very simple, but I think the most surprising thing is it doesn't produce the pretty pictures, right? We're used to things like Hubble, getting those nice detailed pictures. That is not at all what Kepler does. It just does simple measurements of the brightness.
Could the WTF star be explained by kind of a glitch in that data?
Well, yeah, I mean, if we actually look at it, it's very unimpressive. I mean, that's what it looks like. This is the actual data. We are saying that this could be an alien megastructure. Some of these variations that we realized, we only realized because we're looking at big galaxies. And so when you're looking at big galaxies, you can see how that galaxy is affected as a whole because they're
spread over
they're
many
spread
pixels.
over multiple
Yeah.
pixels.
Where is Tabby's star in that? Is it just on one pixel?
It's on 1 pixel. Tabby's star is on 1 pixel. Let's say if the star happens to slightly vary on 2, then that can create some artificial measurements. This is why you get evidence outside of Kepler that is not affected by these, because that will help us too.
I think it's fair to say that all the hypotheses, they're all pretty contrived. We just need more data to explain anything that's going on.
It is the best target we have for efforts to search for signals from extraterrestrial intelligence. So while we're busy ruling out these natural hypotheses, we're also going to point radio telescopes at Tabby's star just in case.
Jason and Tabby will point the Green Bank telescope at the WTF star in a couple of weeks' time to see if there are any strange signals that might be evidence of extraterrestrials. Maybe Tabby's star's not that weird. What would our own sun look like if we could step outside the solar system? What if there were inhabitants around Proxima Centauri? They had their own Kepler Space Telescope. What would they see pointing it at our sun?
It's fair to think about what we'd look like to put it in context, and we would be a WTF object. We would be really weird.
I guess so. I guess our sunlight would dip in a very weird, irregular way.
Exactly. We would be a weirdo. We have 8 planets, all orbiting at different speeds, dwarf planets, moons. And so you would think Mercury would be a small eclipse, plus Venus, sometimes plus Earth, and then you get Jupiter, which is a big one, Saturn, which is a big one. We would not make sense to the inhabitants of Proxima Centauri.